DC and AC. The two voltages or electromotive force F types are DC and AC. DC means direct current and AC means alternating current. DC voltage stays at either a constant or variable, negative or positive value in time. An example of DC voltage is the plus 12 volts from a standard car battery. Direct current DC. The term direct current refers to the fact that direct current DC flows in the one direction only. The diagram below shows a simple DC circuit consisting of conductors, a voltage source and a load. As there is only one path in a series circuit, an open circuit will reduce the circuit current. E0. Car batteries and torch batteries etc. produce a direct current. When power distribution was introduced, Thomas Edison promoted the use of its electricity supply. His proposed DC generator advantages included their compatibility with storage batteries for use in blackouts, the easy paralleling of multiple generators to cope with peak demands, the easy metering of DC power consumption. Disadvantages of DC. It was not easy to change voltage levels that was needed for different voltage requirements for different applications. More expensive to install and maintain due to the sizes of conductors and wires required. Required more generation plants. Tesla promoted AC. Advantages of AC included fewer generator plants, easier conversion to lower usable voltages, longer reach for the power distribution networks. Alternating current AC. Alternating current AC is an electric current which continually reverses polarity and direction, whereas direct current DC flows only in one direction. Alternating current AC is normally produced by a generator or an alternator. 3 coils of wire are wrapped on the rotating part of an alternator known as the armature. The armature with the coils of wire rotates between 2 permanent magnets. The usual waveform of alternating current in most electric power circuits is a sine wave, as shown below. When the coils above the axle rotate clockwise down past the south pole, and the coils below the axle rotate up past the north pole, they will cut through the magnet's magnetic force field, producing an electric current traveling in one direction. As the armature continues to rotate, the coils that pass the south pole now pass the north pole, and the coils that pass the north pole now pass the south pole, and this produces a current flow in the opposite direction. This is how an alternating current is produced. Referring to the diagram of an alternator, you will notice that the armature windings are at 90 degrees to the magnetic lines of force. At this point, zero current will be produced. Maximum current is produced when the armature windings are in line with the magnets and are cutting through the magnetic force field. The diagram below shows 2 half-cycle peaks of an AC waveform from an alternator. One half is from 0 going to positive, and the other half going from 0 to negative. In the transmission of power, there is a significant loss associated with the transmission of low voltage using high currents. Typically, a AC power transmission uses a very high voltage with a low current. Power is distributed at 330,000 volts, which is too high for the average domestic residence. Service transformers are used to change the voltage from this high voltage to the lower voltages suitable for domestic or business users. Voltages are supplied in the range that consumers typically use when they plug in kitchen appliances, televisions and electric lamps. Residential and commercial users get standard access to 230 volts AC. And they also have access to 415 volts AC. If required, when they build a new house or have a 3-phase air conditioner installed. The diagrams below show an alternator as the source of voltage in a simple circuit. The current flow corresponds to the first half cycle, positive flowing in one direction. The negative half cycle corresponds to the current flowing in the negative or opposite direction. Because the alternator spins constantly to generate AC, the current direction in the circuit above is constantly changing. The frequency at which the current changes direction is determined by the number of the alternator's full rotations every second. Our home's general-purpose outlets, GPOs and lighting circuits are 230 volts with a frequency of 50 Hz. This simply means that our house lights are effectively blinking on and off 100 times a second.